For those of you who aren't fully aware of like what a pallet is, right? Maybe we could start there. The pallet you can think of from a non-technical perspective. It has some business logic, right? So you have these frame pallets. We have these frame pallets in Substrate, and they have some business logic. And you can actually use multiple pallets together. Think of each pallet like a Lego, like a little Lego block, right? So you can put these pallets together, combine them together like Legos, and form this runtime, this beautiful runtime with all this logic, right? So when we're demoing these learning sessions for you, we're going to cover, in this case, the Treasury Pallet, one pallet. All right, so that's what we're talking about today, the Treasury Pallet. And the presenters will be myself. I'm a support engineer at Parity. For those of you who I haven't met, I look forward to meeting all of you. And then there's Justin. Justin is a solutions engineer here at Parity. Justin, if you want to wave your hand, I don't know if they can. And then there's Daniel. Daniel is also a solutions engineer in Parity. I'm in Pennsylvania, Justin's in Washington, and Daniel's in Warsaw. So pretty cool. So the agenda today, V kind of hinted, we're going to talk about a few things. We're going to talk about the purpose of the Treasury Pallet, why it exists, some high-level features. We're going to talk about how it works. How does this pallet work? And we're also going to talk about its usage, the Treasury Pallet in the context of Substrate and Polkadot. The pallet itself has several dependencies and dependents. Justin will be talking about that. And we're also going to be doing a demo. So Daniel prepared this beautiful custom Substrate chain with the Treasury Pallet that he'll be demoing. Number 6, we're going to get pretty heavy in the code. So that's the agenda for today. So why does this pallet exist, right? Very basic question. So really, from a high-level perspective, this pallet exists to realize the concept of a treasury in code, right? We're talking about each pallet is some business logic. So this is the business logic for a treasury in code. We can put that pallet in a runtime, and we can actualize a treasury on a Substrate chain. Polkadot has a treasury, right? Kusama has a treasury. The screenshot that you see there, I took that this morning. That's the Kusama treasury. You can see all the different aspects there. We're going to talk about it. So why does the treasury exist? Well, you can think of the treasury as it has a pot of funds. It has spendable funds. You can see there the amount. I think it's like 444,000 Kusama, right, in this case. So it has some spendable funds, and these funds can be used to make sure that the chain is running smoothly and make sure that the chain is growing. So we want the chain to grow, right? So yesterday, the team, we were discussing some specific examples that the Treasury solves. Justin, maybe you could highlight a few of those.
Yeah, for sure. So to kind of contextualize it, the problems that the Treasury solves, I wanted to frame some of the problems from the point of view of parachain teams and end users to help guide some of the thinking as everybody's listening to the presentation. So without Treasury, from the eyes of a parachain team, they might frame problems like, how can I guide my community to work on the projects that are the most important? And how can I ensure fairness in payout? Users might frame problems, users or people in the ecosystem, they might frame problems like, how can I find interesting work inside of my ecosystem? How can I suggest things that I want to work on? Things that contribute to this project, things that are part of this ecosystem, and how can I get paid for work in crypto? So Treasury solves these, and Bruno, I'll keep going if you don't mind.
Yeah, go for it.
So so one piece of it is development and growth. Treasury drives community activity. It's meant to encourage collaboration in the community and build engagement, but it also helps it grow through incentivizing different initiatives. It can serve as a way for a project to help guide its community to help build on the things that they believe need to be built. The people who drive a treasury are able to build in what kind of say, what level of say they have in what proposals are put forward. And we can go into how that is configured a bit later. But that's all for now. Maybe we can talk a bit about some terms that we're going to use today.
Yeah, so cool. So we're taking a journey here, right? We're trying to understand the Treasury Pallet and why it exists, how it works. I was muted there. So we're doing a little journey here, right? We're trying to understand why the Treasury Pallet exists and how it works. From that screenshot there, you can see there seems to be a concept of proposals. There seems to be a pot of funds. There's a spending period. So let's discuss some of these key terms. You're going to see that throughout the Treasury Pallet logic, there's a concept of a proposal. So a proposal you can think of as an account that's going to request some amount of funds from the Treasury, right? Maybe the account is requesting, I want 100 Polkadot, right? So that's what we consider a proposal in the Treasury Pallet. Beneficiary is the account that will receive that value, that amount. So a proposer could be a different account. Someone proposes some amount, some value that they request from the Treasury. The beneficiary is the account that will receive that amount if the proposal is approved. And then the other key term that you're going to see throughout the Treasury Pallet is deposit. So it's either we call it deposit or we call it a bond. So for every proposal, there is a deposit associated with it. And that's something that as a substrate developer, you configure it on the chain. So for example, Polkadot, the deposit is 5% of the proposal value. So if you're requesting 100 dots, 5% of it, right? Five Polkadots, 5 dots, right? Is going to be reserved as a deposit. So what happens is if that proposal is approved, you get that deposit back. The proposer gets that deposit back. If the proposal is rejected, you get slashed that amount. Okay, so you can think of that as like an anti-spam measure. Okay, and then of course we have the pot of funds. So that treasury, that pot of funds, it's not created out of thin air. The funds are raised through different means on the chain, and Justin will talk about some of these methods a bit later in the presentation. So this screenshot here, it's Polkadot.js, and you can see right there, it's the modal window, the pop-up window there, and it says submit treasury proposal, right? So as a user, if you were to create a treasury proposal on Polkadot.js, this is what you'd see. And you can see some of those key terms. You can see the proposal account there. You can see the beneficiary, the value, right? It says 0 there, but you'd want to put something a little bit higher than 0. The 5% that's configured specifically for Polkadot. On your custom substrate chain, you can change that percentage in the configuration. And there's also a minimal bond. So whichever, either it's 100 or it's 5%. Okay. So a little in summary, the treasury consists of a pot of funds, proposals. Proposals are created. And once these proposals are created, they're voted on by council. So council is a different palette, but they're voted on by council. And then the council will reject or approve them. And you can see that there's a proposal queue there on the screenshot, and there's also an approved queue. So the approved queue are proposals that have already been voted on, have been approved, and they're waiting. So what are they waiting? So this is the other key aspect of the Treasury Pallet. You can see in the upper right-hand corner, this is the Polkadot Treasury. It's got a 24-day spending period. You can think of that as the waiting period. Okay, so these proposals that have been approved in the approved queue in the bottom, they're waiting for those 24 days when the spending period gets activated and the spend funds method in the Treasury Pallet gets executed. Okay, that's the day that you can think of like the spend day, where the Treasury will spend its funds on each one of those approved proposals. Right, and we're going to take a deep dive in that at the end of this session and look at the code for that, which is pretty cool. All right, so that's a little bit about how it works and some of the features that we have with the Treasury Pallet. Some interesting things about the Treasury Pallet, if you're going to use it as a developer, it works off of origins, right? So throughout Substrate, we use origins. And I kind of hinted at it when I said the word council. You can see there in this diagram that on the left-hand side, there's a column of origins, and each row is an action you can take. These actions is in Substrate what we call like the extrinsics. Like, so for example, the first row there, the action to create a proposal, we'll call in the code, it'll call the extrinsic proposed spend. Okay, so in the code, that will create a proposal and add it to the storage. When we create a proposal, some of you who have already seen the Treasury, the Polkadot Treasury, there isn't much there in the proposal. Like, you're not going to see metadata there, for example. You're not going to see a description of what the proposal is, why they're requesting that fund. All that we're storing in Substrate storage is the proposal ID. Okay, so that's one interesting aspect of this palette. So all we're storing is, like, if we were to create the very first proposal, it's going to get an ID of 0. So all you're going to see in the storage, you're going to see, okay, there's ID 0. You're going to see the amount that the proposer is requesting. So maybe they're requesting 100 dots. You're going to see who proposed it and who the beneficiary is. That's it. Very lightweight storage. Okay, so that's one interesting aspect that you should know. The second row there is the approval, right? So there's a proposal in the queue. There's a proposal already created in the storage. How do we approve it? Well, there's an extrinsic associated with that. Approved proposal. So the thing with approved proposal is that someone with some account, you could say, someone with the approver origin has to call that extrinsic. And the approver origin is something that, as a Substrate developer, we have to configure that in the Treasury Pallet's configuration. So the approver origin could be a collective, it could be a council, it could be pseudo, it could be one account, it could be multiple. Okay, so that's something that you're going to see in the configuration later, that's the approver origin. And you can see there's also a rejection origin. So whoever has rejection origin will have the ability to reject a proposal. And then spend origin, whoever has spend origin will have the ability to fast track, to like kind of say, like, I'm going to create a proposal and spend the proposal at the same time, create and approve. All right. So there's the concept of different origins when you're working with this palette. So next I'll hand it off to Justin to talk a little bit more about use cases in the Treasury Pallet.
Yeah, so I'll talk a bit about how Treasury is used in Substrate and Polkadot today. And I'll talk through it in 3 levels. So the first is kind of the application level. The second is the configuration level, and then the palette level. So the first is kind of like how end users might interact with governance. The second is how a chain like Polkadot is configuring it. And then the third is kind of how other frame palettes, how other developers are interacting with Treasury. So Bruno has a screen, but you can see the screenshot of PokeAssembly here. And I included that because PokeAssembly is a very popular application for users to interact with different governance and funding features on different pallets, on different chains. Right now, you see a screenshot of somebody looking at on-chain treasury proposals for Polkadot. To walk through what the process, what the flow of submitting a proposal looks like. So first, a user will introduce a treasury proposal through the app. An application like this will be connected to their wallet. It'll sign their transaction, which makes the call to the chain, and that call is the propose extrinsic on Treasury. And once that's done, the proposal is created. From there, council members and users can collaborate off-chain on the proposal. Now, I say off-chain here because of something that Bruno brought up earlier. The Treasury Pallet doesn't actually store any metadata about the Treasury, about the proposal. But if you look here, you see all these proposals have a lot of text and a bunch of stuff associated with them. Like on this number 158, you see this title. And if you click into it, you'll also see a bunch of other metadata associated with it, like a description, like a very detailed description, perhaps comments. All of this data is off-chain. So moving on, a council member may create a collective motion for the approval. So what does that mean? So Bruno and I have mentioned the council, and the council is an instance of a separate palette called collective. And what's common and what's configured in Polkadot is for Treasury to be configured with the approve origin, can accept either a root or 3/5 voters of the council. So this kind of leads to the process that I've shown you, where the motion that's brought to the council is whether or not to approve your Treasury vote. So now that the motion is created, council members can vote aye or nay on the call. If passed, it's approved, and then the council executes the approval. They call the call that you've created, which is the approve extrinsic. At that point, the proposal is accepted, and it moves over to an accepted queue, so to speak. And everything in that accepted queue, like Bruno has mentioned, is going to be going to have their spends occur during the spend period. And this is that 2-day or so period that Bruno mentioned. I can't remember the exact time. Okay, so if we can move on to the next slide, we can look at one more screenshot. I just want to show one more piece on proposals. So you can see here's an example proposal. This is on Moonbeam. And this is a screenshot of the same app, PokeAssembly, that's based off of Moonbeam's instance. And this is just a screenshot of the description, but what I wanted to show here is kind of the norm that governance users or Treasury users have built up to write very detailed proposals for what they want to pass. Like in this proposal, for example, you'll find milestones, you'll find deliverables, scope, a lot of like very detailed project planning. You know, it's very likely that this norm is built up because people want to get their votes to pass. They're scrutinized by the council, and they want to submit the best plan possible to prove that they're going to have a successful project. But that's a common workflow from the app user point of view. Moving on to configuration. So I'm looking at Polkadot's configuration specifically, and it looks like one of my changes didn't take there. But Some notes about Polkadot's configuration of Treasury. So for one, it's a single instance, and this just means that there is one Treasury on Polkadot, and this is also a common configuration throughout the ecosystem. There's one Treasury. This is made up of whichever groups that have been configured for that Treasury, and there's no more. That's all that I mean about this. There's more you can read about it for instantiable pallets that can be made into an instance. And I'll leave a link for that in the slides. Maybe we can share these slides. So the second is an 80-20 split of fees to Treasury and block author, respectively. This is also a really common configuration. This isn't just for Polkadot, but what this is that so the Treasury needs to be funded, right? We need to fill it with the money to be able to pay the people, the Treasury users. So we have a configuration where slashing and payments for transaction inclusions and any staking inefficiencies get sent to the Treasury and the block author. Now it's kind of technical because this is not actually a configuration within Treasury. So I don't mean to confuse anybody and say this is what you can set inside your config trait, but it's just super common, and it's very central to your chain if you include such a configuration in your Treasury. So I thought not to exclude it. So that's how the Treasury is filled, but also how do tokenomics work? How are funds removed from the chain? Well, teams are, building a substrate chain. They're fully able to implement their burning, their token issuance, however they like. But what's common is that token burning is configured through Treasury. Treasury its purpose is to fulfill these Treasury needs, but it also has a nice function for implementing some burn every spend period. And so for Polkadot, for instance, this is 1%. But it's important because it ends up being a part of Polkadot's tokenomics. And finally, this is a setting for Polkadot, but it's also pretty critical for other teams who want to set up Treasury. At least one group configured for Pallet's custom origins. So like we've gone through, origins represent who is executing, who is calling this extrinsic. And you might not want this to be some solo individual. You might not want them to have this much power. So Polkadot has some sense, and their idea is to allow for a council vote to execute approve origins, for example. You don't want one person making these decisions. And but yeah, so it can check for root or an execution from council. And finally, there's one more extrinsic there, which you might have seen has sort of extra power. It's the spend extrinsic. And this one actually includes the functionality of both propose and approve. So it's doing a bit more than some of the other extrinsic, and Polkadot has completely disabled this through a configuration setting, and that's never ensure origin. And that's all I have for this one. If we want to go to the next one. Okay, great. So to talk about pallets, other frame pallets are interacting with Treasury. So there's bounties. Bounties behaves kind of similarly to Treasury in that there are tasks or projects which can be defined, and these tasks can be evaluated and paid for. The beneficiary paid off, essentially. So bounties kind of shares in Treasury's funds by implementing one of Treasury's traits. And it does this, not to move too far away from what it's actually doing, but it does this to implement its its process that's very similar to Treasury's payout. It kind of looks through its own approved bounties, and it says, you know, for each of these, was it approved? Do I have enough budget left allocated by the Treasury? If so, then I'm going to mark this bounty approved. And this one is a bit of an honorable mention, but because it's a bit, it's not directly involved with Treasury, but there is a piece of Treasury that's pretty interesting. So there's an on-imbalance trait in Substrate, and this is meant to handle imbalances. If you're not familiar, you can think of imbalance kind of like some credit or debit, or maybe some issuance or removal of funds that your code does not consider final. Like, say some tokens were issued, but you don't want to you don't want this to be set in the chain. You want this to be settled, maybe removed from the same amount is removed from somewhere else in the chain. And the same can be said for a negative imbalance. So maybe some tokens were removed from someplace, and with your chain's logic, you believe that this should be this amount of tokens should be added elsewhere. So all of these pallets listed here implement the default function for the imbalance trait. So for staking, this is for payouts and slashes. For identity, this is slashes associated with identity kills. Democracy, it's all slashing. Election fragments, it's for candidate loss or member kick. And so they implement this default. They use this default function from the imbalance trait, but this function falls back to Treasury's imbalance handler. So that's kind of interesting. That's all I have here. So if we can move on to dependencies. Okay, so to talk a bit about the other pallets that are either directly involved or often associated with Treasury, I'll speak about both crate dependencies, but also pallets that are just often used with Treasury. So starting off with the simplest ones, there's bounties and child bounties, which both directly depend on the Treasury crate. We can say they're both tightly coupled with the Treasury crate. And those are the only ones that are dependent on it. As far as dependencies go for Treasury, there are none in frame, but it's often configured with traits that are implemented by balances and bounties. So for balances, it implements both currency and reservable currency, and it uses this for things like taking reserves and slashing those reserves. And for bounties, it's spend funds. And spend funds is just a handler that fires whenever Treasury spends funds. So for example, this is how bounties is able to configure some function that fires whenever Treasury spends funds, and it's able to share in Treasury's pot in that way and to handle any imbalance. So there's a few other cool handlers in Treasury, and these make it very useful for other developers who want to work with Treasury and kind of extend it without changing the code inside. So these are handlers for 3 actions. There's on unbalanced, which can be configured to fulfill either on slash or burn destination. On slash fires whenever funds are slashed. So that happens during each rejection. If you have a function that you need to fire during a proposal rejection, then you can implement this. And burn destination fires on each burn, and each burn happens during each spend period. So if you need information about a burn and you need it to fire during the spend period, you can implement this. And that's all I have for this slide. I think we can move on to the demo.
So as Bruno said, the demo is built on a substrate node created from the template. And at first, let's have a quick look at the palette configuration. So basically, the palette in my demo is configured almost the same as in Polkadot, but with small differences. I mean, the first and main difference is in approving and rejecting policy. I mean, in the Polkadot, proposals can be approved or rejected by the council or a super user. In my demo, it can be done only by a single user, just for the ease of demo. The second difference is a spend period. While in the Polkadot, it's 24 days. In my demo, it's 1 minute, just to show you quickly how the palette works. And the last difference is the superpower extrinsic. In Polkadot, it is disabled. In my demo, it will be shown with the super user power. So yeah, let's go to the Polkadot UI. So yeah, at first, let's have a quick look at the Treasury view in the governance tab. So in this view, we can see a spend period that is 1 minute, as I previously said. Also, we can see the pod, and that is quite big, I would say. Also, we can see a burn amount. It was mentioned by Justin about burning some funds with each spend period. And for now, we have no proposals and no approved proposals. Before I start with playing with the extrinsic, let's have a look how the spend period works without any proposal. So at first, with every 1 minute, so every 10 blocks, Treasury Pallet at first allocates the whole pot. So you can see it here. Then it's time for allocating benefits to the beneficiaries, but without any proposal. There was no allowance, no beneficiaries. After the allocating the funds, we have the burning stuff. So 1% of the pot is being burned, and after the burning stuff, the whole pot is rolled over. So yeah, let's create our first proposal. I'm going to the extrinsics, and let's say Bob wants to give some money to Charlie, for example. I am creating a proposal. So the transaction has been sent, and in the Treasury view, we can see that a proposal has been created, that Bob wants to give some money to Charlie. He wants to give him 1 unit of our tokens. Bond is a mentioned deposit. It's 5% of the payment reserved from the Bob account. And let's have a look how it looks on the blockchain. So yeah, basically, the first action taken is deposit is reserving the deposit. I mean, some balance is reserved on the Bob account. And then we have an information from Treasury Pallet that a proposal with 0 index has been created. As you remember, the deposits can be slashed when the proposal is rejected, or can be returned when the proposal is approved. So at first, let's reject the proposal. The proposal will be rejected by Alice, and we're gonna reject the proposal. So I am submitting a transaction with rejection. Transaction has been sent. We can see that there is no proposals, and we should see some interesting info in events. So at first, that deposit has been slashed from Bob account, and also we can see the information that a proposal has been rejected. So yeah, now it's the high time to see how the happy path works. So let's create an extrinsics, let's create a proposal and approve it. So let's say Bob wants to send some money to Eve that time. So yeah, I'm creating the proposal. Proposal is created, so let's approve it. Alice will approve. The ID of that proposal is 1, because it's incremental job. I'm approving it. It gets approved. We can see that the proposal is moved to approved section. And it gets funded. So let's check how it looks. So yeah, as I previously said, spending time has begun. So the funds was allocated. Then the deposit is unreserved and returned to Bob. Then Eve gets the amount of money from the pot that Bob requested. Then we have an information from Treasury Pallet that the proposal has been done and awarded. And then we have some stuff about burning money every time and the rollover of the money. So yeah, that's the main part. And let's go to the superpower extrinsic called send. In my demo, it can be done only via root account. So with spend function, we can just create a proposal and approve it. And let's say this money will go to Parity. So I am creating the proposal and approving it. So yeah, it's done. As you can see, it's in approved proposals. And let's check the events. So in comparison to creating a proposal and then approving it, we can see a different event from Treasury Pallet called spend approved. And the main difference is that in this function, in this call function, we don't have a deposit. Basically, we trigger that function and any deposit is blocked. So yeah, the spend period occurred, and we can see that Ferdi gets some money from the pot. So basically, that's it from the demo. Thank you for attention. And Bruno.
Okay, cool. So for the remainder of this session, we're going to show some code, discuss some code. For those of you who are interested, you can remain. For those of you who are not, you're welcome to leave. Okay, so I'm going to share my screen. So what you see there is the Polkadot configuration for the Treasury Pallet. Okay, so this is how Polkadot uses the Treasury Pallet. This is the code for how Polkadot uses the Treasury Pallet. This is the config, right? So line number 1 here, or the first line here in the config, you can see it's establishing a Treasury Pallet ID. This line doesn't seem like much, but it is. From this line here, it's taking the Treasury Pallet ID that's defined a little bit higher, right here, Treasury Pallet ID, right? And you can see right there, this line is where, based on this line, we create the account for the pot, for the Treasury. That's going to be the account on the chain that holds the funds. So very important line, right? So we're creating that account, okay, based off of this information here. The next line here in the config, this is what Justin was talking about, like Vincent, like the dependency of like the balance palette. So this line right here, if we were to do this, it no longer has the balances palette as a dependency. Okay. The reason why we have the balances palette as a dependency is because we like to use the currency trait, and we use the currency trait that's implemented in the balances palette. Okay, that's what we're stating right here in this line here, which is pretty cool because the currency trait gives us a lot of features. And then you can see in the config, there's different origins. So as a substrate engineer, substrate developer, right? I always like to pull it back to that perspective, right? This presentation. So as a substrate developer, this is where we specify the origins. And this is Polkadot, right? So Polkadot saying, hey, for the approver origin, we're going to have approve origin, which is defined right here, right? So when we were talking in the presentation about like collectives, things like that, right? You can see palette collective. Okay, so it's not one account, it's palette collective. So as a chain developer, as a substrate chain developer, you define these origins. Okay, that's where it's happening right there. And then Justin was talking about the handlers, right? The on/. So what happens in this ecosystem of palettes that you have in the Polkadot runtime or in the substrate runtime? What happens when there's a slashing, right? When something gets slashed? Well, on/ for this handler here, we're defining it to Treasury. So this is saying like on/. So for example, when Daniel was demoing and Daniel was saying like, hey, you know, here's the bond, here's the 5%, the deposit that this proposer is putting down, right? So they're asking for 100 Polkadots, 100 dots, and they're putting down 5 dots as the deposit, as the bond, 5%. If it gets rejected, which Bob at one point in Daniel's demo, Bob got rejected, right? He had to pay, right? So where does that money go to when Bob gets slashed? Well, that's defining the config here. And in this case, it goes to the Treasury.
Yeah, here, so the trait bound here is it's on unbalanced, and so Treasury just has an implementation for on unbalanced. So whoever was configuring this just decided to look for that.
Yeah, that was Brian Chen. So the other interesting one is spend period, right? So Polkadot has a spend period of 24 days. You saw that in the UI, right? The user interface there, right? Where is that 24 days coming from? Well, spend period, this word here, spend period, it's defined up here, right there. Look at that, 24 days in the constants. Okay, so as a chain developer, when you're configuring the palette, the Treasury palette, you can change this. Like Kusama, I believe, is 6 days. Okay, what is spend period? Again, spend period is when the spend funds, when the Treasury spends its funds. Okay, so that's configurable. Another one is the burn. So burn here, we can see it's defined burn equals burn. Like, what does that mean, right? Well, burn is defined as a constant up here. Burn. This is a deflationary measure. And you can see Polkadot is burning 1% every spend period. Right? So Polkadot is inflationary. We're burning here. It's a deflationary measure. We're burning 1% of the Treasury. And you can change this. All right. So that you can see that this is the configuration. You know, when Justin was talking about that never ensure origin, that spend origin is disabled, this is how we're disabling that origin. We're essentially saying in Polkadot, we're saying, hey, no one has the power to do an approve and spend at the same time, or a proposal and spend at the same time, proposal and approve. Okay, through this line here in the config, never ensure origin, which is pretty cool. Any questions on this config, Polkadot's config, Treasury Palette? All right, cool. So the other thing that I want to show you if we switch here, we're switching from the Polkadot code base. We're going into the substrate code base now. What you see on the screen is the substrate code base. We talked about extrinsics, right? For some of you, it's like that have never seen it. Like, here's an extrinsic in the code. This one in specific is proposed spend. Daniel demoed this extrinsic for you. This is the extrinsic that will create a proposal. And when I said it's very lightweight, you can see that the parameters for this function, all it takes in is the origin, the value, right? The amount that the proposer is requesting, 100 dots, let's say. And if this proposal is approved, the beneficiary, what account does this value go to? The 100 dots. That's it. That's all it takes in for this extrinsic. And the body of this function is right here. You can see that we do a couple checks here. We make sure that these are legitimate accounts. And then the next line here is pretty cool. This is the deposit, right? We've been talking about that deposit, that it could potentially be slashed. This is where we calculate the deposit. So calculate bond is a function that is based on that configuration, where in the Polkadot configuration, for example, we have this proposal bond. Do you see that proposal bond? Proposal bond is defined up here. Proposal bond. And look, it's set to 5%. We can change it as substrate developers, right? We can change to 1%, 5%, 10%, right? That proposal bond comes into play inside the Pallet's code right here in the calculate bond. So it's going to take the value, let's say 100 dots, and it's going to call calculate bond with that value, and it's going to return 5% of that, which is the bond. We're then going to proceed to use that currency trait, right, which is implemented via the balances palette in Polkadot that we saw. And it has a reserve, which we're going to use a reserve on that account, the proposer's account, with the bond amount. So we're going to reserve 5% of that value on the proposer's account. We're going to hold it. All right, so you can see these two lines of code, pretty interesting, right? And then we proceed and we take the proposal count, we increment the proposal count in storage. We then add that proposal into the proposal storage. We now have a proposal created on the chain, right? In the block. It'll go in the block. Okay, so that's an extrinsic. I just wanted to highlight an extrinsic for you. Any questions on this extrinsic? Can anyone tell me how much, like, what's right now in the Treasury in the Polkadot? I think there's, I took the screenshot, the one that in the presentation. I took it this morning, and I don't know if you can see, it's kind of small, but there's 34 million dots right now in the Treasury for Polkadot. Are any of you interested in seeing how the spend funds function works, right? That's the function that will take that pot of funds, go through each proposal, and the ones that have been approved, it will send the fund to that account, the beneficiaries. Anybody interested in that? Should we talk about that? Because we are on time here. Yeah? Okay, I see a few hands. All right, so let's talk about that. So right now we're inside the Treasury Pallet, right? This extrinsic, it's defined inside the Treasury Pallet code. There's a lot of code in here, but if we scroll down, there should be a line here called a function called spend funds. Right here, line 501. Do you see that? Spend funds. So what's interesting when we were looking at this, when the team was looking at this, right? We saw this is interesting because there's a spend funds function right here, spend funds. But if we scroll to the top, bear with me for a second. There's also a spend funds trait. Okay, so remember when Justin was talking about like the bounties, and that the bounties can also execute spend funds. Well, keep that in mind as we go over the spend funds. Okay, so there's this trait called spend funds. And if we scroll to the bottom back to line 501, we're going to look at the function spend funds. Okay, so a few things that are important here is the first thing that we're doing here that is important to highlight is that we're taking the amount that's inside the treasury, the pot. Okay, so whatever amount is inside the... Oh, go ahead.
Do we want to go over how it's called?
You want to talk about that?
Maybe it's called inside of one of the hooks, right?
Oh, down here? Oh, this. Oh, you're saying the initialize. Yeah, we'll talk about that. Yeah. So that's a good point. So remember that spend period, right? Polkadot has a 24-day spend period. Kusama has a 6-day spend period. And that's defined in the config under spend period, right? We define that as Substrate developers. There it is, 24 days, right? So every 24 days, that spend funds function that we're looking at right now will be called, right? So where is that called? Well, if we look in the code here, in the palette code, we're still in the palette code, there should be a section here, initialize, a hook on initialize. Right here. So you can see there's the macro. Oh, there's a macro here, right? This is a macro, hooks macro, specifically the on initialize hook. So this is interesting. We take in the block number, we use the modulus operator, we grab that spend period, which is defined in the config. So for Polkadot's 24 days, and if it equals 0, it's payday. If it equals 0, right, we're spending some funds from the treasury. So that's how that spend funds gets executed. That's how it works every 24 days, or every 6 days, or however many days you would configure it to. In Daniel's demo, I think it was like every 1 minute, right? So we just to demo it for demoing purposes, right? So that's where that gets called. So what happens when that gets called? Well, here's the logic, right? The first thing that we do is we grab the amount that's inside the treasury, inside the pot, and we set it to budget remaining. We then fire off a little event saying, hey, we're going to be doing some spending. We then proceed to grab the treasury's account ID and just set it to a variable at this point, right? And the core of this is that we're going to iterate through all the proposals that are in the approval queue, right? So there might be 1, there might be 0, there might be multiple. And as long as the value of each proposal is less than or equal to the budget remaining in the pot, then we're going to call this deposit creating function here. This is where the proposer account, or the beneficiary account gets its money. This is where the money gets sent. The crypto gets sent, right? So this is where that happens. And we're going through each proposal and we're calling this as long as there's money left in the treasury. And when we're done looping through this or iterating through this, if there's, and then we reach this function here. This is the point where maybe, Justin, you want to talk about this? This is the bounties aspect.
Bounties has a very similar function. It has a very similar structure to Treasury. This function that we're inside of right now, you can imagine something almost identical to this. So bounties receives that budget remaining. So however much Treasury wants to allocate it for it, this imbalance, this handling of positive or negative funds that are not settled. They also get weight and missed any, which is a Boolean on whether to, I don't quite remember this one, but we could look into it. But anyways, the point is they have a function that's almost identical to this one, where instead of iterating through approved proposals, they're just iterating through approved bounties, and then they're receiving that budget remaining, and then they're checking whether the amount for a given budget exceeds it or not. If it does not, then they will count that budget. They will count that bounty approved. So it's almost like instead of you can think of it almost like instead of proposals here, they're just using bounties instead.
Right.
Yeah. And they're able to do that because they have this trait on their config for one of their associated types that's spend funds, and then they just pass in Treasury enabled in order to hook in.
So yeah, I think that even like if we look at the Polkadot config, I believe it has it there too. Let's see here, Polkadot config, spend funds right here. Do you see that?
I got it the other way around. That's what I meant to say.
So this here, if you can see the little pop-up there, it says runtime hooks to external pallet using Treasury to compute spend funds. So the only reason that this is possible here is because spend funds is a trait that I showed you way up in the code, right? Way up in the beginning, that bounties will actually implement. And I have the tab here. I'm not going to go into bounties, but I'm right here. I'm now inside of the bounties palette, and you can see right here, it's got the spend funds, right? And if you look at the code, it looks really similar to the code that we're going over, except it's bounties. All right, so just so you know. Okay, and that gets called right here in the runtime hook section. All right, so what does that mean? Well, it means that we're going through this queue of approved proposals, right? We're sending some funds to each one that's been approved, right? And once we're done going through that queue, if there's still money in the pot, you could say, we then proceed to the bounties. It'll iterate through that queue, make sure that all the money that needs to go out there goes out. If we still have money in the pot, we then proceed to burning. So this is where the burning happens in the code. This is where we do a burn get, which we saw in the config. It's set in Polkadot to 1%. So this is a line of code that we burn 1% of the treasury. Okay. So that's pretty much it. Like I don't want to go too far more. Any questions on this? I thought this was a cool function that was unique to this palette that, you know, it'd be nice to kind of cover. Cool. So thank you all for joining us. Hopefully it was good. And yeah, thanks.